Okay, today we're starting a new little section called logarithms. And how is it related to the other section? Ho, ho, ho! Well, logarithms, new word here, logarithm. Logarithms are inverses of exponential graphs. So, here's an exponential, y equals 2 raised to the x power. And the inverse is y equals, no, it's 10, sorry about that, y equals log base 10 of x. This is the original, this is the inverse. Now then, remember the way that we checked it yesterday is we said, well, the x and y's have to switch. That was the whole deal. They switch places. The x and y's have to switch places. So, let's pick some points. Yeah. So, if I pick 1, 10 to the 1 power, that's 10. 10 to the 2 power. That's 100. 10 to the 3 power, that's 1,000, right? 10 to the 6 power is 1,000,000. 10 to the 9 power is 1,000,000,000. 1, 2, 3, 4, 5, 6, right? So, what does that mean for these guys? Well, if they're inverses, that means when 10 goes in, 1 has to come out. And when 100 goes in, 2 has to come out. And when 1,000 goes in, 3 has to come out. Right? Well, let me show you that. That is true. Let's just look. Okay. So I'm going to put log. See, there's a log button right here. This is log base 10. This is log base 10 of x. So you don't have to write the 10 in there because it's automatically log base 10. And now let's look at the table. We want to say what happens when 10 goes in. Let's say what happens when 10 goes in. So we just don't need that there at all. Oops. What did I do? There we go. That's right. Independent, dependent. Start and okay, so. Oh, I only gave it 10. Ha ha ha. That's good. What if we do this? Oh, I can't show you on my calculator. How sad. Oh, I can. Because I can say, hey, what happens when 10 goes in? Hey, what happens when 100 goes in? Hey, what happens when 10 goes in? When 10 goes in, 1 comes out. Can we even see that? Hey, probably not. It's not very bright, is it? Oh, there we go. 10 goes in, 1 comes out. What about when 100 goes in? Silly boy. When 100 goes in, 2 comes out. Isn't that what it's supposed to happen? Yes. Alrighty. So, let me zoom out back out of here. When 10 goes in, 1 comes out. When 100 goes in, 2 comes out. When 1,000 goes in, 3 comes out. If you put 1,000,000 in there, 6 comes out. What do we notice? We notice that the answer to the logarithm is the exponent. See, 10 to the 2 power is 100. So if I'm taking the log of 100, that's 2, because 2 is the exponent that makes 100. 6 is the exponent that makes 1,000,000. Let's see if we can do that again. See if we, well here, let's just do it this way. We'll say that 2 to the 3rd power, we know that means 2 times 2 times 2, that's 8. Now if I was changing that to be a logarithm, I'd have to have log base 2, log base 2 of 8, and the answer to the logarithm is the exponent, right? The answer to the logarithm is the exponent. So if 2 to the 3rd power is 8, then when I take the log of 8, the log base 2 of 8, I get 3. This is the exponent that makes the base equal the number inside. 3 makes the base equal the number inside. So look at this one. 5 to the 2 is 25. So log base 5, because the base has to be the same. 5 is the base, 5 here. The answer to the logarithm is the exponent that makes 5 equal the number inside. The answer here is always the exponent. So, what if I gave you one like this? Whoops. Log base 3 of 27. And I said, hey, what's the answer? Well, you'd say the exponent that makes 3 equal 27. 3 to some power equals 27, right? What's the exponent? 3, right? I know that log base 3 of 27 is 3 because 3 to the 3rd power is 27. Each of these are related. The logarithm is the inverse of the exponential function, so that the exponential function and the logarithm are related in this way. If this is the base, it has to be the base of the logarithm as well. If it's the base of the exponent, it has to be the base of the logarithm. Here, 3 is the base of the exponent, 3 is the base of the logarithm. Okay? And then the answer to the logarithm is always the exponent that makes the number here equal this value. Let's try some more, just to make sure we understand. Now you have to be able to go from logarithms to exponents and from exponents to logarithms. So, what if I said 3 to the 4th equals 81, and I wanted you to write me a logarithm? Do you know what would go down here? Do you know what would go inside? Because see, there's always something inside. There's something down here, and there's something over here. Well, you know the answer is always the exponent. So 4 has to go there, right? And you know the base is the same. 3 has to go there. That means 81 is the only number that can possibly go there, right? Do it again, just to make sure. Just to make sure. Well, let's go backwards. What if I told you the log base 2 of 32 is 5? The log base 2, could you go the other way? Could you tell me what the exponent is? Well, I know 5 is the exponent on which number? 5 is the exponent on 2. See? 2 to the 5 power is 32. So if I give you an exponent, you should be able to write a log. If I give you a log, you should be able to write the exponential. Let's try that. No mas, huh? Ooh, I'm going to give you a tricky one. Well, it's not really tricky, because you know what this is, right? 16 to the 1/2 power. I don't know if you remember, but 1/2 power, if the exponent's 1/2, that's the same thing as taking the square root. 1/2 power means square root. So if it was the 1/3 power, it would mean cube root, and the 1/4 power would mean 4th root. Well, anyway, the square root of 16 is 4. So 16 to the 1/2 power is that. If I wanted you to write me a logarithm, remember there's a number inside here, there's a number down here, and there's a number out here. And the answer to the logarithm is always the exponent. So that means 1/2 has to be there. And then the base of the exponent has to be the base of the logarithm. So the only number left is that. So the log base 16 of 4 is 1/2. Why? Because 16 to the 1/2 power is 4. Easy, sleazy, lemon squeezy. What about this one? We'll try and remind you of these values. 2 to the 1/3 power is 8. If you forgot, negative exponents make fractions. Negative exponents make fractions. So this is really 2. 2 to the 1/3 is the same thing as 2 is 1 over 2 to the 3rd. So 1 over 2 to the 3rd is 1/8. If you remember that, you are in business. So what's the logarithm? If I want the logarithm, I know that there's a number inside, I know there's a number down here, I know that there's a number out here. -3 is the exponent. So -3 has to be out here. What's number on the bottom? Well, it has to be 2. The base of the logarithm is the same as the base here. That means that 1/8 is inside the logarithm. The log base 2 of 1/8 is -3. Why? Because -3 is the exponent that makes 2 equal 1/8. That's the ticket. Let's see if we can solve a problem like this. What if I asked you, what if I asked you the log of, let's see, the log base 3 of 127. If I said, hey, what's the log, what number, what exponent makes 3 into 27? Now we just talked about that, right? Negative exponents really make fractions, right? So 3 to the -2 would be 1 over 3 squared. That's 1/9, right? So 3 to the -3 would be 1 over 27. So this is -3. Why? Because 3 to the -3 equals that. 3 to the -3 equals 27. We know that if we're trying to solve a logarithm problem and we're looking for the exponent, all we're doing is saying 3 to some power equals that value. Let's try another one. What if I had 64 right here and 8 right there, and I wanted to know what is the exponent? What is the exponent on 64? What exponent on 64 makes 8? That's my question, right? What exponent? Now remember, we were talking just a minute ago. I said 16 to the 1/2 power is 4. Why? Because 1/2 really means square root. Square root of 16 is 4. Well, the square root of 64 is 8, right? The square root of 64 is 8. Well, that means that the 1/2 power of 64 is 8. So 1/2 is the exponent, right? The answer to the logarithm is always the exponent. So 1/2 is the exponent that makes the base, 64, equal 8. Let's see, one more and then we'll be done. How about a real nasty one? Log base 2/3. Any number can be the base of a logarithm. You don't have to worry. And 4/9. So I'm asking you, what exponent can I put up here that will make this come out? Right? That's the question. What is the exponent that makes 2 into 4/9? Well, hopefully you know 2 to the 2nd power is 4 and 3 to the 2nd power is 9. So that means 2 is the exponent that makes 2/3 equal. solving logarithms, always look for the exponent that makes it work. That's the whole. Alrighty. Logarithms are the inverse of the exponent. They're going to give you exponents and ask you to write logarithms. They're going to give you logarithms and ask you to write exponents. And they're going to give you just logarithms that don't have an answer, and you have to find the answer to the logarithm. But you know this. You know the answer to the logarithm is the exponent. So, like I said here, 2/3 to the 2 power. Hey, that's 4/9. So the answer is 2 because it's the exponent. You know, here we were doing 16. 16 to the 1/2 power is 4. Here we were doing -3 is 27. Oh, that's supposed to say 27 over there. 27. There we go. -2 is 1/9. -1 is 1/3. Nothing to it. You should be able to do today's homework. Bye.